Okay guys, so this next part here has some of the verbiage in this real world problem, not relevant to the math of it, but I went ahead to just kind of decode anything that might be unfamiliar to some people. So Tavon is training for a duathlon, which is a race that consists of running and cycling. Okay, so two events in this race, running and cycling. The cycling leg is longer than the running leg of this race. And what that lingo just means is that there's more cycling than running in the race. So when Tavon trains, he rides his bike more than he runs. Well, that makes sense. During training, Tavon runs 4 miles for every 14 miles he rides his bike. Identify the ratio associated with this problem and find its value. So I need to find the ratio, I need to find the value. So the numbers I read, he runs 4 miles for every 14 miles on his bike. Okay, so 4 to 14, I can do that as 4 over 14. Now this is not its value yet because this can reduce down. It can be simpler. Okay, I know that they're both even numbers, so I know that I could divide both sides by 2. 4 divided by 2 is 2. 14 divided by 2 is 7. So 2 over 7 for the value. 4 to 14 for the ratio. Letter B, it says use the value of each ratio to solve the following. When Tavon completed all of his training for the duathlon, the ratio of total number of miles he ran to total number of miles he cycled was 80 to 280. Is this consistent with Tavon's training schedule? Explain why or why not. So his training schedule is what we just figured out in the last one. Okay, so in his training schedule, there's a value of 2 over 7. And I'm going to write that little note on the top of mine here. So 2 over 7 value for training. Just going to put that off to the side. What I need to know is this ratio consistent with this training schedule? Okay, so we're going to see why or why not. So I'm going to start by making this ratio into fraction form. And is this its simplest form? No way, absolutely not. That could definitely be reduced by a couple of numbers. For example, every time both numbers have a 0 at the end, I know one quick way to make these numbers smaller is to divide both sides by 10. Okay, now I have a smaller number to work with. But I'm noticing that it can still reduce down. They still share a common factor. They still, 8 can be divided by 4. 28 can be divided by 4. Okay, so I'm going to divide both sides by 4. And I get 2 over 7 for the value. Is that comparable with the training schedule? Well, yes, it is, because they have the same value. And what we recognized and what we tried to disprove, but we're unable, is that if two ratios are equivalent, they have the same value. Okay, so yes, it is consistent with his training because this ratio, 880 to 280, has the same value as his training schedule, which is 2 to 7. Okay. Go ahead and pause if you need to write this, or if you would like to put that in your own words, feel free. No, feel encouraged to put it in your own words. Okay, and in this last one, letter C, in one training session, Tayvon ran 4 miles and cycled 7 miles. So here the ratio is 4 to 7. Did this training session represent an equivalent ratio of the distance he ran to the distance he cycled? Explain why or why not. Okay, so what we need to do here is first find the value and then talk about if that one is also equivalent to 2/7. So I'm sorry, or 2 over 7, 2 to 7. We want to see if it's the same value. So here 4 to 7, I could write that as 4 over 7. And does that reduce down? Can this be in a simpler form? They don't share any common factors. 4 only has factors of 1, 2, and 4. 7 only has factors of 1 and 7. So they do not share any common factors other than 1. They cannot reduce down. So this one has a value of 4/7 or 4 over 7. Is that comparable? 2 over 7 was the other value. Are those the same? No way. No. So my answer is no, they are not equivalent. Because they do not have the same value. And what we learned today is that, and going back to our content goal, that we can decide if 2 ratios are equivalent by figuring out if they share the same value, which here they do not. Lesson summary, the value of the ratio A to B is the quotient A over B. So we learned that in yesterday's lesson. This is just kind of reiterating that idea. And then if 2 ratios are equivalent, they have the same value. That was the big takeaway from today. So making sure we're reducing every value down to its simplest form in order to decide if they do share a value, that means they're equivalent. If they do not have the same value, they are not equivalent. All right, awesome job, guys. Go ahead and work on your problem set.